Well, welcome everybody. I'm Laura Tremore Spears with the Center for Leadership in Environmental Awareness and Research, or CLEAR, and I'm a program coordinator along with Brendan O'Leary that is here. And we have one of the center directors, Melissa Runji Morris, here for the seminar. And we just wanted to start with one slide that shows all the various ways that you can stay in touch with what CLEAR is doing, and particularly our website, clear.wayne.edu. Our upcoming events are always at the bottom of that page. And so seminars like this one, we really encourage you to monitor that web page and tune into these seminars because they are so important to our work in the Superfund research program relating to the environmental and health effects of volatile organic compounds and other contaminants in the environment. So with that, today I'd like to introduce Rita Loch-Caruso from the University of Michigan. She's a toxicologist with an emphasis in female reproductive toxicology, and she's done some recent work on 1,4-dioxane in the city of Ann Arbor, but as a volatile organic compound and one that's present in groundwater, which is not considered to be an exposure pathway in Michigan for environmental and personal health effects. When you're in an urban area that has a municipal water system, this is really novel and important work because it's showing the effects of this and other volatile organic compounds. So Rita's here with Bob Bailey and Jack Eaton and other partners like Kristen Schweinhofer and Shane Morrison. So we've got lots of folks on the presentation that can answer questions. And with that, Rita, I'll let you take that away.
All right, great. Thanks so much. And really, thank you so much for inviting me. It's a pleasure to be here. Before I go far at all, I want to congratulate the CLEAR team on your success becoming a recently funded Superfund Research Program Center. It's a huge achievement and well-deserved. So this talk I'm going to give today, it's about this 1,4-dioxane groundwater contamination. That's a huge concern to the communities in and around the city of Ann Arbor. And the talk I'm giving, it's an outgrowth of countless collaborative efforts by members of a group called CARD, the Coalition for Action on Remediation for Dioxane, and with special acknowledgement going to Dr. Bob Bailey, who's on the line today and is really the driving intellectual force for the novel exposure pathway work. So as I said, the Coalition for Action on Remediation for Dioxane CARD, it's this collaborative group of citizens and other stakeholders and representatives from the impacted community jurisdictions, going from the local to the regional to the state level, and even including in our meetings. We have monthly public meetings, which right now are Zoom and are recorded, but these meetings are regularly attended by representatives even from our U.S. Congresswoman, Dingell, and often by EPA representatives as well, representatives from the Region 5 EPA. CARD also participates in numerous community activities, including going to various fairs. This was from a relatively recent green fair in the city of Ann Arbor, where we work to engage the community and inform them about not only the history of the 1,4-dioxane contamination, but what the current status is. So the community became concerned about 1,4-dioxane because of potential health concerns. And at the time when it was first discovered, not a lot was actually known about health hazards from 1,4-dioxane. And we were told that maybe it wasn't even, that big a deal at various times during the last few decades. But we have since come to learn quite a bit about 1,4-dioxane toxicity, and a lot of it is driven by the very rapid rate at which the 1,4-dioxane gets absorbed into our body through the lungs and the gut. So it's thought that nearly all of 1,4-dioxane that is inhaled or is swallowed is going to enter into your body and circulate in your blood. It's been linked to liver and kidney disease, and it's been ranked in the second highest risk ranking for carcinogenesis by various agencies like the United States Department of Health and Human Services, the US EPA, and the International Agency for Research on Cancer, who have ranked it in their second highest level ranking as reasonably anticipated, likely, or possibly carcinogenic to humans. This ranking is based upon rigorous laboratory experiments indicating it is carcinogenic. And the reason it is to have a ranking in the highest level by these agencies, you have to have rigorous epidemiologic data on human exposures, and that's sadly lacking still. So Gelman Sciences began using 1,4-dioxane as a solvent for cellulose triacetate in a manufacturing process to make medical and scientific filters. And they began this in 1966 and continued using 1,4-dioxane for this purpose into 1986, so for 20 years. And they, the quality of their filters was such a commercial success that they really ramped up production quickly during this time. And the company estimates it used about 850,000 pounds of 1,4-dioxane over this 20-year period. The problem is that as they're ramping up their production and they're generating industrial wastewater, they had no plan for disposal of the chemical wastewater initially. So what did they do? So they started storing it on site and disposing of it on site. Some of these actions were permitted by the state and some were not so permitted by the state. Initially, they put the 1,4-dioxane contaminated wastewater into unlined man-made ponds. These ponds occasionally overflowed and drained. So here's the ponds. Here they're lined because this is a more recent photograph of the Gelman site. The ponds occasionally overflowed into surrounding areas, including a rather infamous marshy area, and into nearby streams. And in particular, you see here is Third Sister Lake, which has a major part in the story I'll tell you in the next slide. They also had an open burn pit where that was unlined, where they would burn solvent waste. And at one point, they erected these very tall spray irrigation towers, and they would shoot out the contaminated wastewater into the air. And the thought was, well, it's going to evaporate. And it's true that once 1,4-dioxane is exposed in air to UV light, it will start to break down. The problem is it also distributed it as aerosolized water droplets. And nearby neighborhoods complained about a fine mist being a relatively common occurrence. And that irrigation could be up to 44,000 gallons a day of wastewater just shot up into the air. And of course, and then what didn't evaporate landed on the ground and contaminated the soils. They also dug a deep well, approximately 1 mile deep into the bedrock, and disposed of. I could not find a total amount of wastewater that was disposed into this deep well. What I did find was an estimate of 9 million gallons of wastewater injected into that deep well just in 1 year, from 1983 to 1984. So how was it discovered? I alluded to the lake, and it is a big part of the story. It was discovered by a graduate student, Dan Bicknell, who now lives again in the area. But when he was a graduate student at the University of Michigan, Dan visited the Saginaw Forest, and the Saginaw Forest is a forest area of land that's owned by the University of Michigan, and it has this Third Sister Lake in there, a very pretty little lake. And when Dan was at Third Sister Lake, he noticed that there was a stream emptying into the lake, and this really puzzled Dan because he was always told that this was a spring-fed lake. So where is this groundwater stream coming from? And he found it was coming from the Gelman Sciences property. He took a water sample from the lake. He brought it to his friend who worked in an analytical chemistry laboratory, had him analyze it, and they detected concentrations of 1,4-dioxane. It was 0.3 parts per billion. Well, Dan wrote this up in which I understand is a 3-page paper for a class in graduate school. And then he mailed it to the DNR, the Department of Natural Resources, which was the state agency that was in charge of regulating environmental contamination at the time. The initial response was not one of the state of Michigan's finest moments. An environmental chemist, a water quality specialist, was quoted by the newspaper as saying, "I'm inclined to believe Bicknell's data is not worth a toot." So that was a pretty sound dismissal. And that was in 1984. Dan subsequently went back and took further water samples, including samples from the stream running into the lake, and found more evidence of 1,4-dioxane. And he actually persisted in trying to get action about this contamination. And it was by 1987, there was a complete turnaround with the DNR listing the Gelman site as the second worst site in the state for toxins. So what led to this dramatic change in attitude and perspective from the DNR from 1984 to 1987 were some pretty disturbing findings. Over 40 private drinking wells had been found in the intervening time to be contaminated with 1,4-dioxane. Some of these wells had exceedingly high concentrations. One well that was used as a drinking water source had concentrations of 200,000 parts per billion. That's micrograms per liter. I just tend to go with parts per billion because it's a little easier. But 200 parts per billion. And some of these wells were as far as 1.5 miles from the site. So the DNR became quite alarmed that this was an ideal groundwater contaminant that was beginning to spread, and that was at very high concentrations. So how did it become the oldest and largest single 1,4-dioxane contamination site in the United States, as described by Thomas Moore and William D. Giuseppe in their publication in 2022? Well, location had a large role to play in it, as well as the very high groundwater concentrations I told you about in the previous slide. This is a topographical map of the area, and the star indicates the approximate location of the Gelman Sciences site. And you can see that there's a dramatic change in elevation as you move from the Gelman site. And much of this is driven by a major geological feature of the Huron River. And what you can't see underneath it, and the reason why this area is hilly, is because of remnants from various ice ages. And so there's a rather complex geology of soil and shale beneath the ground level that we can't see. So location is very critical. Also important is 1,4-dioxane's relationship to water. So 1,4-dioxane's chemical properties make it very miscible, completely miscible in water. And it's wants to preferentially partition to water. It's resistant to bacterial breakdown in the natural environment. It's poorly adsorbed onto leaves and clay and soil. And once it gets into environmental waters, it's highly mobile. It easily moves into groundwater from surface soil and surface water, and it has a high potential to generate long groundwater plumes. Complicating the situation further is that 1,4-dioxane is poorly degraded by conventional sewage treatments and by conventional drinking water treatments. And these characteristics of 1,4-dioxane allow it to accumulate in environmental waters and persist in environmental waters. So you could just sort of sum it up that 1,4-dioxane loves water. Because of these characteristics of the site and 1,4-dioxane, the plumes have continued to spread over time. These are two graphs. On the left is 1992, showing the estimated boundaries of the plume, and on the right is the estimated boundaries of the plume in 2021. These graphs, I want to note, were created by Roger Rale, who's the chair of CARD, and he's also the chair of an older citizens action group on this problem, srsw.org. And you can find these maps and more on the SRSW site. So you can see that in 1992, the site was thought to be much smaller than the current site. These are showing plumes to an estimated 1 part per billion, with the maximum, just showing the max as greater than 100 parts per billion or micrograms per liter. And the dark arrows show the major axes of the plumes. And you can see that in the beginning in 1992, there's thought of as 2 major axes, and it's still described this way often as having the western plume and the eastern plume. But by 2021, we've come to recognize that the spread of the plume is much more complex, that there are still these major eastern and western axes and flows of the groundwater, that the contaminated groundwater, but also that 1,4-dioxane is coming off in various, sometimes unexpected directions and ways. So the spread of the 1,4-dioxane plume is really grounded on the 3 things we talked about before: the high concentration of 1,4-dioxane at the source, the complex geology, and the love of 1,4-dioxane with water. You can get a different perspective in this map, which plots a relief map of concentrations along the plume in 2020. These are from 2020 values. And again, this is created by Roger Rale. And what it shows is more gradations of concentrations of 1,4-dioxane, and shows just there's still a very high amount of 1,4-dioxane, a lot of dioxane remaining at the source, and a concerning elevation here, right where there's a bend in the direction of the flow of the major flow axis in the east. So we've talked about why the plume has spread, and I think it's very logical at this point to ask, why wasn't it contained? Why hasn't more been done? What's been limiting the ability to stop the spread? And one of the major, besides all the factors we just went through, is that there are many legal tangles governing the regulation and remediation and cleanup of this site. And there's a lot. And I'm not going to go into all of the legal wrangles there are and tangles that there are. I'm just going to hit you with the main point, which involves the fact that this site remediation is overseen and determined by the circuit court. It began with a state suit on Gelman Sciences to clean up the site and water. That suit was then lost in a court of appeals. This then led the state and Gelman Sciences to join into a legal consent judgment to manage the contamination. The problem is that changes and updates to Gelman Sciences' required response actions only occur by negotiated amendments to the consent judgment. And the current consent judgment in force right now was adopted by the court in 2011. There is a 4th amendment to the consent judgment that is pending. Other regulatory notes of importance are that Michigan does have a residential drinking water criterion set at 7.2 parts per billion. There's also something called a groundwater surface water interface criterion. That's kind of important. This is where the groundwater meets surface waters like streams, bodies of water, ponds. And Michigan has set this at 280 parts per billion. But remember what I just told you in the last slide, we have this consent judgment. And the current consent judgment from 2011 allows the residential drinking water to be 85 parts per billion and the groundwater surface water criterion to be 2,800 parts per billion. The other thing that's important to know is that the Michigan law only requires management of risk, not necessarily cleanup. The US EPA, through the Superfund law, or CERCLA, publishes a substances priority list in which they list the contaminants of most concern, environmental contaminants of greatest concern on a priority basis. And 1,4-dioxane is on that Superfund substance priority list, and it's number 220. The US EPA has also conducted risk evaluation of 1,4-dioxane and issued a health advisory that estimates that drinking water exceeding 0.35 parts per billion increases the risk of cancer to 1 in a million over a lifetime. It's important to note this is non-enforceable. It is not a drinking water standard. US EPA does not have a drinking water standard for 1,4-dioxane. And finally, I just want to note that 1,4-dioxane was included in the Lautenberg Amendment to the Toxic Substances Control Act, and it was included as one of only 10 contaminants listed for the initial first full risk assessment. So that is an indication of the concern that the US EPA has about 1,4-dioxane as a contaminant. So the court in 2005 decided that and agreed with Gelman that they would allow and control risk of exposure and thereby assumingly risk of health concerns by establishing an institutional control of a prohibition zone. And so this court ordered a prohibition zone limits human contact with 1,4-dioxane by prohibiting almost all groundwater uses in the zone. There's a couple of minor exceptions. Unfortunately, the prohibition zone, though, also allows the contamination to spread under and through the city of Ann Arbor at concentrations that are, and I tried to correct this, but I forgot, that are up to 2,800 parts per billion. And remember, that's the 2011 negotiated third amended consent judgment. And so they're allowed to go up to 2,800 parts per billion within this zone. The rationale for the prohibition zone was that the contaminated groundwater would remain below the ground until it discharged into the Huron River, where it would be diluted. Not only is that a bad policy decision, that dilution would be the solution to pollution, but we also now know that the underlying rationale is not true, because we now have evidence that 1,4-dioxane is nearing the surface prior to discharge into the Huron River in the heart of the city of Ann Arbor. So here again is that topographical map, and it shows again the approximate location of Gelman Sciences and the general flow of this eastward flow of the plume from Gelman Sciences eastward. And it shows that it is heading right into the heart of Ann Arbor and through Ann Arbor neighborhoods. On the right, we have a cross-sectional area showing changes in the ground elevation along 150-mile length of that plume. And it shows high flow areas where the 1,4-dioxane is spreading most rapidly. And you can see that going from the west to the east, that we have a plume predicted based on modeling that would come to the ground surface. And what I have here are 3 sampling areas shown on the elevation map: monitoring well 1, monitoring well 2, and a stormwater drain that's located in the that's in the West Park. It's the so-called Allen's Creek stormwater drain. And what you can see is that, first of all, that there is a concentration gradient consistent with flow from the higher contaminated area to the lower. And you can see that this coincident with this change in elevation, and the elevation decline is quite steep here, that we are at a point here where it's feasible that 1,4-dioxane would in fact be nearing the surface. So the data we have on shallow groundwater contamination is summarized. The highlights are summarized here, that in 2016, we had the first indication that there was a problem and all these detections are in this general area of the West Park in the heart of Ann Arbor. In 2016, 1.9 to 3.3 parts per billion of 1,4-dioxane were detected in 2 temporary shallow wells in an investigation by Gelman Sciences of this eastern down gradient area. This initiated a monitoring plan by EGLE, which is the state agency that's now in charge of environmental contamination. And in 2017, they detected 4.4 parts per billion in that West Park stormwater drain that peaked in 2017. That was in 2017, they detected 4.4, it peaked at 49 parts per billion in 2020, and it continues high into 2021 at 33 parts per billion. Down gradient from the West Park drain on Chapin Street, they found 8.7 parts per billion in 2019, and this increased to 28 in 2020, again, consistent with this flow of the groundwater carrying contamination further into the city of Ann Arbor. And for the first time since 2017, they detected 1,4-dioxane in a pond in West Park at 1.1 parts per million, 1,4-dioxane. So CARD actually had a major role in this identification of this shallow groundwater contamination. Vince Caruso, my husband, was riding a bicycle through West Park, and it was nighttime, and he had an accident, and he went back in the daytime. He slipped on ice, and he was really confused because there had been no precipitation in recent days. And he found seeps coming out of the ground. And that one thing led to another, with CARD group being a major force in pushing for better monitoring for shallow groundwater contamination. But there remains no regular monitoring of shallow groundwater in Ann Arbor. EGLE is using sampling of seeps, sampling of surface waters, and sampling of stormwater drains as proxies for shallow groundwater contamination. And unfortunately, there is not currently a plan to monitor the shallow groundwater contamination. The discovery in 2016 of 1,4-dioxane in those 2 shallow wells did stimulate a lot of concern in the state agencies. At the time, it was MDEQ. There's been a lot of changeover over names of state agencies that are in charge of environmental contamination. At the time, 2016, it was the Michigan Department of Environmental Quality. They issued emergency rules on 1,4-dioxane because of this shallow groundwater. And emergency rule 2 was a residential vapor intrusion screening criterion of 29. This was later revised and relaxed to 1,900 parts per billion And this was based on taking into account that 1,4-dioxane. Remember, I told you 1,4-dioxane loves water, it kind of goes where water goes. And so 1,4-dioxane does not readily evaporate from soils to any greater extent than water evaporates from soils into that ground space. It's not something like trichloroethylene. And so its vapor intrusion risk was deemed to be less than initially thought. However, neighborhoods in the plume path have a high water table, and damp, wet, or flooded basements are relatively common in these neighborhoods. So the problem is that 1,4-dioxane and water like to travel together. So when water infiltrates into basements to make them damp, wet, or flooded, 1,4-dioxane is going to move into those spaces with the water. And when the water vaporizes, evaporates into the indoor air in the basements, so will 1,4-dioxane. And so this is just a depiction. This is our graphic abstract from our publication showing those major points. So Bob is really the expert, Dr. Bob Bailey, on the risk assessment, and he made a lot of assumptions in building a model to estimate risk from groundwater infiltration into damp, wet, or flooded basements. Like all modeling, assumptions are key. There are a lot of assumptions in this process. They're all outlined in the publication. But I'll give you the main ones here. We made assumptions consistent with US EPA risk assessment processes, like on life expectancy and exposure and inhalation risk value. And this is where I meant to correct these. These should be superscripted. Out on the on the file of these slides that I will make publicly available, we'll have these corrected. This should be vapor exposure. We estimated based on ceiling heights and based on the exposure manual. We assumed a temperature of 21 degrees centigrade and 3 ventilation rates. And this is the estimation for the damp basement, just to give you a milestone. And from those, we obtained the projected residential air concentrations using a US EPA screening calculator of 6.3 microgram 1,4-dioxane per meter cubed for increased risk of 1 in 100,000 and 0.63 microgram per meter cubed for increased risk of 1 in a million. And with that, we then estimated the concentrations in 1,4-dioxane in groundwater that would elevate the indoor air to the level of those protective concentrations or beyond those levels of protective concentrations. And the 3 most important factors in the modeling are the rate that the groundwater enters the space, the volume of the space, and the ventilation rate. So we took the basement humidity, which is really an indicator of how much groundwater infiltration there is, right? Because that's what's making the basement damp or wet or flooded, is the groundwater is getting into the basement. And we used our 3 ventilation rates, the low ventilation rate and the medium are based on, oh gosh, the 10th percentile and the median percentile for the US EPA. I guess it's from the risk assessment manual, I'm not sure, but they're used in EPA risk assessments. And the high rate came from a study of older homes in the Detroit basement, in the Detroit area. And what you can see here is that the major factor that determined the groundwater that was critical for presenting a risk was the infiltration of water into the basement, which makes sense. There's a direct relationship. And that when you had a damp basement, the ventilation rate had no noticeable impact, and flooded basement was also significant. And so what we estimated is that there was an increased risk of 1 in a million if groundwater was above 115 parts per billion. For a damp basement, 3.9 parts per billion for a flooded basement, and that increased risk was that cancer risk was increased 1 in 100,000 if the groundwater concentrations were 1,150 parts per billion. So currently, groundwater, as I said earlier, because of the consent judgment, is allowed to go as high as 2,800 parts per billion in Ann Arbor, and although a decrease to 208 parts per billion is proposed pending acceptance of the fourth consent judgment, it's still, we predict, would not be sufficiently protective at a 1 in a million increased cancer risk for damp or flooded basements, although it would be protective for, if you accept it, an increased cancer risk of 1 in 100,000, although flooded basements would still be at increased risk. In addition to the surface water contamination, there are concerns about spread of the plume that are now contaminating resident wells that are beyond the estimated boundaries of the plume. Remember, the estimated boundaries of our plume are about there. And I overlaid here a map that was published from Scioto Township showing results from Scioto Township wells sampled between November 21 and May 2022. And each of these blue and brown dots represents a well that was sampled. They're all outside of the plume area. The red, when you see red type, that is pointing to a well. The dots are a little bit hard to see, but they're pointing to wells that had measurable detectable levels of 1,4-dioxane. These are residential drinking water wells. All the detections are below 7.2 parts per billion. However, there's concern because, again, the first notice these people had that they have 1,4-dioxane in their drinking water is because the township decided to do this sampling program. And I would say that CARD was part of this, that members of the township trustees are regularly attend CARD meetings and pushed for this. There's some important features here. Some of these contaminated wells are pretty far from the boundaries, up to a mile or more. There's a cluster of wells that's within half a mile of the Huron River, and one contaminated well is only 1,000 feet from the Huron River. And in addition, there was a well here that is in Ann Arbor Charter Township, where drinking water residential well actually was detected that exceeded the 7.2 parts per billion criterion. So these are really concerning. Seeing this northern expansion of the plume is very concerning for the city of Ann Arbor because it gets over 90% of its municipal water from Barton Pond in the Huron River. So 1,4-dioxane is an emerging national concern. We are not in this alone. In fact, there's an international concern because it's being found across the world. This map was generated based on data from a time when the EPA required municipalities with a certain size that delivered water to an area, a population of a certain size, to look for 1,4-dioxane in their water. And the black dots show detections, any municipality that detected 1,4-dioxane in their water, and the green dots show where municipalities detected 1,4-dioxane exceeding 0.35 parts per billion 1,4-dioxane. And remember, this is the US EPA health advisory level for an increased risk of 1 in a million increased cancers upon exposure in drinking water to 1,4-dioxane. So the CARD group has been working over time to get action in various ways on this contamination, to monitor it, to get action, to better remediate and clean it up. And one of our more recent activities has been to get the impacted, to work with the impacted jurisdictions to encourage the state to request the US EPA to evaluate the site as a Superfund site. And look, that has happened recently. And we are currently at this stage, really, we're past the site inspection, and we're at this stage now in the process. And we are anxiously awaiting any day the results of the EPA initial assessment and its preliminary score. We're anticipating that, in fact, it will exceed their criterion and continue in the assessment process. So this is a summary slide of our situation with the 1,4-dioxane Gelman contamination. It's a modification of the graphical abstract from our partner publication. And it just shows that at the Gelman site, there became groundwater contamination that spread in multiple directions. This contamination has impacted residential wells. In addition to those Scioto Township wells I told you about, I emphasize those are because those are new findings. But prior to that, the county has closed over 200 private wells because of contamination with 1,4-dioxane. So those, now we have these additional wells from the Scioto Township. But so several homes have been impacted, residences and businesses have been impacted by having their wells closed. In addition, the city of Ann Arbor actually closed one of its wells. It had a well tapped into the northwest supply well that was found to be now contaminated, and so they closed that well. And we have issues of risk for contamination to surface water, either near the site. We know that there was contamination of creeks and ponds and lakes near the site, and there are potential other risks as we go further downstream. And we have risks from contaminated water coming in contact with residential basements. And the values here are just Michigan, this should be a Michigan drinking water, are the Michigan current criteria values versus the ones that are currently applied to Gelman because of the third amended consent judgment that's still in force. So again, I just want to emphasize that this contamination is a serious concern in our community. Community residents take this very seriously, very concerned. This is a photo from a 2018 Ann Arbor Town Hall meeting. You can see that this was standing room only. And this is a gymnasium of the elementary school, and it was packed. And this line is the line of citizens who want to ask questions. And the line extends the entire length from the stage out the door into the hallway of people who had questions or concerns that they wanted to have addressed at the meeting. And finally, I just do want to emphasize collaboration, I think, is really helpful and important. CARD is a major force, I think, in helping our community deal with this contamination. And I really want to just do a shout out for all the work of everyone who participates in CARD and acknowledge their efforts and their interests, and thank them all for their help. And thank you for your attention. I'm happy to take any questions.
I don't see any questions in the chat yet, or was there somebody who was going to speak up?
Laura Tremor Spears.
That who was on now?
Did somebody have a question? Or you can post them in the chat. This is,
They could also raise a hand, I think.
yeah, or raise their hand. I do have a question, actually, Rita. You mentioned West Park and the 1 part per billion concentration. I know I've seen ducks and other, aquatic organisms in that park. Can you talk at all about any of the low-level chronic exposure effects that are suspected of occurring even now?
In terms of wildlife or
Well,
for
yeah,
humans?
just in the environment, environmental effects, yeah.
I think that for humans, the contact with the water at 1 part per billion is not a major concern because dermal exposure is much less than absorption by dermal exposure is much less than absorption through the lungs or through the gut. So in terms of the aquatic organisms, I'm not as keen on that. I'm not as up to date on it. I just do know that they did modify that part of the impetus for modifying the groundwater to surface water interface, that GSI value, and making it more stringent was based upon aquatic species. So, but that level is 280 parts per billion. So I don't know if I've addressed your question.
No, that's good. Are there chronic low-level exposures or effects that are suspected from people's basements right now in Ann Arbor?
Not in basements. I don't think in basements right now. I think what we have, well, we don't know. There was a modest monitoring program of indoor air. The placements might or might not have been, you can argue about that, whether they were the best selected sites. But, the groundwater contamination at basement level is still low. But what that one cross section showed is that it's higher up gradient and it is coming down gradient. It is coming to the area in Ann Arbor where that contaminated groundwater will be in the general vicinity of basements. And so I think the way we look at those results is that this is a warning. We hope that other people do more work on this. We think that some site evaluations are necessary, and it should be more than just indoor air. You need to know what's in the water outside the basement, as well as what the indoor air is inside the basement. And you might want to even sample water and the inside of the basement. But those would be the kind of measurements that we hope for. And in the meantime, we see this as a warning. We raise this as a flag that if we act, we can prevent a real problem. And if we don't act, that there are going to be hundreds of residents that are going to be having their basements in direct contact with groundwater that's contaminated with 1,4-dioxane. And unless that flow or concentration unless the concentration is abated or the groundwater flow is interrupted, that 1,4-dioxane is coming down gradient.
There's sort of a related question in the chat about how many communities downstream of Ann Arbor also get their drinking water from the Huron risk, and could the exposure risk be much greater in the long run?
It's a great question. My understanding is that there's no municipality downstream that pulls from the Huron River municipal water. However, it does empty into the Great Lakes, and 1,4-dioxane has a very long half-life in surface water and groundwater. So as part of a bigger picture, it is considered an emerging water contaminant of concern because it's persistent. So for example, some people might be familiar, people who study 1,4-dioxane might be familiar with the Cape Fear River Basin, where Detlef Knappe has done a lot of work, for example, and that's an open river. And they have significant levels of 1,4-dioxane there. So I think it's a bad process. Dilution is helpful. It's always better to have less of a toxicant in your body than more, but it's really not a solution for 1,4-dioxane.
Yeah. So other questions that have come up in the chat are, is Gelman still disposing of wastewater in that way? What are they doing with their wastewater
No,
now?
they ceased using 1,4-dioxane in 1986. However, the site remains contaminated. The soils and the lagoons and the groundwater still remains contaminated at a relatively high concentration of 5,000 or more parts per billion. So it's a problem. Right now they're doing pump and treat, where there are several extraction wells where they pump out the groundwater. They treat it to reduce the concentration of 1,4-dioxane, and then they put it back into the surface water. So.
Does that address your question about treatment? Brendan, you had a question about.
Well, my question is specifically focused on shallow groundwater monitoring, and you said you were using seeps and other surface water features to use as a proxy for sampling shallow groundwater. Is there a reason you don't have shallow groundwater wells? Is this a regulatory concern of the well screens being too high or lack of funding?
All right, so I just want to add that the stormwater drains are also in there, and stormwater drains have been the most useful proxy so far. They've not detected any groundwater in surface water streams, although they've been looking, even outside of the West Park area. They did detect it in the pond, and they have not detected any groundwater in the seeps. So the stormwater drains, I just want to make sure that gets into the thing. And then I'm sorry, you asked me one other question about that, though. You actually had a
specifically to it was my understanding you said there, yeah,
why we don't have it,
why you don't have shallow groundwater wells.
the amended consent judgments.
Okay.
So it's all in the consent judgment. So the court would have to order it, quite frankly, or Gelman would have to, and the state would have to agree to that as part of an amendment consent judgment. And unfortunately, my understanding is it's not in the proposed fourth amendment to the consent judgment. So EGLE's been doing these stormwater samplings annually. They started initially, they did it, I think, quarterly in 2017, but now they do it annually. And at least we have those as a proxy and some kind of a measure of groundwater contamination, but it's troubling. It was in a, the community did fight to get into the court discussions for a proposed fourth amendment to the consent judgment, and that did include more monitoring in this area of shallow groundwater, but that was thrown out in the Court of Appeals. And so now they're renegotiating a fourth consent judgment, and it doesn't have this.
A related question we have in the chat actually is how has that communication with the community worked to address their fears and concerns? And, you know, does the community feel informed and trusting of the information?
Well, I can't really speak, you know, I have to be careful on how I address that, but I would say that there's frustration, I think, certainly, and I think that there's probably some anger even in, I'm guessing about that, but the SIO residential well findings from recently, in the last couple of years, those were really pretty shocking to people. And I don't think that was received very well. And so I think that there is some frustration, but there's also recognition that the state law is weak, that the state law does not require cleanup and only requires management of risk. And so we're hopeful. I would say, you know, we're hopeful, and we're pushing. So CARD, for example, just passed a resolution encouraging state lawmakers to adopt polluter pay law, to go back to a more stringent environmental control law we had a few decades ago, and then we loosened those environmental controls. So I can't really speak for everyone in the community, but I think that based on discussions at CARD, that's probably not too far off as an
There's an
response.
update also in the chat from Roger Rail about the pump and treat question that Gelman continues to discharge partially treated dioxane from purged water as part of its ongoing pump and treat system, and that Gelman used to treat dioxane from its purged water to a non-detect level less than 1 part per billion up until 1999. So that sort of speaks to that point too about things having changed. Graham, you've had your hand raised. Do you have a question?
Yes, I do. Hi, Rita.
Hi, how are you?
I'm doing very well. Lovely to see you again. I hope you're still cycling in spite of your partner's fall. You said that
Of
they're no
course.
longer using 1,4-dioxane. So the really obvious question is, what are they using instead? And has anybody examined it?
They're not making filters anymore.
I see. Okay, good.
So there are a few sites, other sites in the country where these filters were made, where they used acetate or triacetate cellulose, and they're smaller and not as big as this one. I don't know what their current status is. I do know that there's a lot of concern about trying to phase down 1,4-dioxane uses because of its persistence and potential to accumulate in environmental waters.
Thank you.
We do have a question about whether the drinking water for the University of Michigan, where you're from, also comes from the Huron River, and whether presumably there's been any concern from the university standpoint.
So the University of Michigan drinking water and tap water is supplied by the city of Ann Arbor. So yes, it comes from the Huron River. Interestingly, there is a well, Natural Sciences building, that was not included in the initial Prohibition Zone. There was a little alcove carved out initially for that well. I don't know what the status of that is right now. And I don't know what Natural Sciences building did with that well. I have no idea.
Reference samples, easy reference samples.
I hope not.
Well, that's all the questions I see in the chat. Are there any other questions or any other comments from your many team members that are also on the call? This is a great talk. We really appreciate your time. Bob, do you have anything to say? Jack?
I would just like to congratulate Rita for doing such a superb job of covering 30 or 40 years of history. You really summed it up very effectively.
Thanks.
I would also take a moment to just thank all of you for the continued work, both on this side and also on the community action side, to really push the community understanding and alignment to feel more effectively with
Great.
It's good to see you.
Thank you.
You were breaking up, Jerry.
But I heard it.
Sorry about that. My headphones must not be working right. So.
And I think for the people that RSVP'd, I have your email address and I can send out Rita's slides if you'd like. I don't like to email bomb people, but if you're interested enough to RSVP, I'm going to assume that you'd like a PDF of the slides. So I'll share those afterwards. And with that, I think we're at 1:30. So any other last questions, comments?
Let me just say that the last slide that will be available through the CLEA website will have links and information about these two articles. It will also have the website for CARD, or CARD's YouTube channel, and a link for the SIA Residents for Safe Water, which is another citizens group that is actively engaged in this.
That's great. Thanks so much, Rita. This has just been an amazing talk.
Thank you.
So
Thank you.
Okay, great. Thanks for your attention. Interest.